Welcome officially, everybody, to No Strings Attached, where for probably the first time at one of these webinars, we get to take the spotlight off of Blues, off of myself, I guess, and instead put it where it belongs, frankly, and that's on our partners who are building real-world products in our space. And this year at Blues has really been the year of the partner. I've said it before and I'll say it again, but Blues really can't and won't be successful without a robust set of partners that trust us to provide robust wireless connectivity, hardware, and services. But frankly, also partners that we trust and can proudly recommend to new customers. So to that end, we recently launched our new partner catalog, available at blues.com/partner-catalog. And this is always expanding and will be a gateway for you to find really the right partner for your particular needs, whether it's early, mid, or even late stage product development. Now, I just mentioned this, but before we really kick things off, if you have any questions during our presentation today, please ask those in the Q&A panel or the chat panel provided in your Zoom UI. Don't bother with the raised hand button, though. That's not going to get you anywhere today. But a question we always get is this being recorded? The answer is definitely yes, it is being recorded. We will get it up on the Blues YouTube channel right here, hopefully later today, maybe tomorrow. But while you're there, I recommend subscribing to the channel, of course. That way you'll get notified of any of our latest, any of our new video content. In terms of intros for our presentation, we can start with the two least important people, and that starts with me. My name is Rob Lauer. I'm Senior Director of Developer Relations at Blues. On our panelist board, as well as TJ Van Tol, who is our Principal Developer Advocate. We are mostly here in a supporting role, though, as the bulk of our time here is going to be uh, on short presentation from our partners, specifically the Arribada Initiative, Prodigy, Chronova Engineering, and J.A.P Lighting Technology. Because again, these are the businesses, the Blues partners who are building product, can honestly provide better insights, advice, guidance for all of you who may be looking for assistance now or in the future. Now, what ties these presentations together today is, of course, the commonality of Blues, and specifically the Blues note card. Now, if you are new to Blues, my 10-second pitch here is that we are here to make wireless connectivity easier and more affordable, both during your POCs and at scale. Our primary hardware product is the note card that you see here, which comes in cellular, Wi-Fi, and LoRa flavors. TJ's holding one of them up as well. We also have a satellite IoT add-on called StarNote. The magic of the note card is really its paired cloud service we call Notehub that lets you seamlessly sync data from your fleets of devices with your cloud platforms in a low-code or even no-code manner. I think that was 10 seconds. With that, I want to get right to our partner presentation. So let me briefly introduce our first partner. That'd be Alex Bucknall, who is a senior engineer at Arribada. So just a quick introduction to Arribada, they are a UK-based not-for-profit specializing in open source solutions for conservation technology, research, and development. They develop open, customizable, and impact-driven technologies for organizations across the globe. Their work is frankly amazing, spans wildlife, environmental, and humanitarian challenges all over the world from Ethiopia to the Antarctic. With that, let me stop sharing and hand the screen over to Alex.
Thanks, Rob. Let's see if this will work. Am I sharing now? Let's do. And there we go. Okay, so I'll do a quick introduction to who Arribada is, and then I'm going to talk a little bit about the kind of things that we're building with Blues. So thanks to Rob's intro, Arribada is a not-for-profit, focusing most of our work in the conservation space, but we also touch humanitarian and environmental work as well. On screen is a snapshot of some of the projects we're doing at the moment. So from top left to bottom right, we've got GPS, GNSS satellite tracking for sea turtles. This is a particularly challenging problem because they don't often surface very frequently. We've got thermal cameras for the arboreal tracking of pangolins in the Cameroonian rainforest. We're using thermal cameras to do this. It's a crazy complicated project. There's a number of environmental issues that concern that one. We've got things like non-invasive tracking tags for manta rays. So without hurting the animals, we can track them and monitor their movements. And then we've got nesting cams to monitor the migration and behavioral patterns of penguins in the Antarctic, which is another amazing use case for us. So Unfortunately, none of these use blues, but I'm going to spend a bit more time talking about projects that we have that do. The first one that you saw as we were sliding through Rob's slides is GeoSeals. So GeoSeals is a humanitarian aid tracking project. So this is being launched out in Ethiopia, in part with some of the UK government aid projects. What we're doing is we're helping them to understand where exactly the movement of humanitarian aid is going. So there's a big problem in developing countries, not just Ethiopia, but developing countries generally that receive aid, is that a lot of this aid actually goes missing on the journey to reach its target audience, and this is generally down to logistics tracking. So what GeoSeals aims to do is it's an end-to-end system for tracking welfare and aid as it enters the country and makes its way to a warehouse. We apply RFID stickers, long-range RFID stickers to the aid packages themselves. They're then picked up by what we call geo hubs that are placed in the warehouses. This could be a healthcare center or actually in a warehouse storage facility. A geo hub picks up these RFID stickers as they come through the entrance of the warehouse. So this is similar to like if you've ever done RFID scanning in supermarkets where you scan the back of the product. This is like that, but longer range. And then once a GeoHub detects an RFID sticker on one of these packages, it then sends this data over Blues to Notehub, where we then pull down the data and provide it to our partners who are interested in where it's going and seeing these packages have arrived. So just a quick technical overview of what's going on. So we have the GeoSeals Hub, which is our long-range RFID scanner. This is largely in prototype phase at the moment. So we're using a Note Carrier F plus an ESP32, which is running on Zephyr and using the Note C library. This sends up our tags over cellular. We are building a version with a satellite backup to use StarNote as well. We do have some questions that I'm going to probably chat with the Blues team about later about coverage. That may be a limitation for us, but we're hoping that we can work through that one. So once our tag data then arrives at Blues, we can then pull it down using their HTTPS routes, and we move the data at the moment into Firebase, where we're using it with Google Looker Studio to create sort of prototype dashboards for our client, the UK government, and the charity organizations that are helping us build this program. It's been a really easy prototyping phase to actually get to this point. Pulling data out of Blues, getting into Firebase, and being able to display the data has been super easy for us. It's been a really nice way for us to make quick dashboards to provide instantaneous visibility on where the packages are going and how the data is moving. Got a quick overview of the actual hardware itself. So it's very much still prototype at this point. We have 10 of these deployed to Ethiopia currently in warehouses that are doing the preliminary trial. So as you can see, we've got an ESP32 feather on the top right and a long-range RFID scanner next to it. Unfortunately, I haven't got a really good photo of the note card, which is underneath it. But you have to trust me that it's there. It's definitely there because it's been working. So this system basically sits in an idle state, in a low power state, until until a PIR event occurs. So this is typically someone walking through the warehouse or a forklift driving past. It'll then wake the system up. It'll scan for tags. If it sees anything in the wait period, it then accumulates all of them until a wake event on an RTC happens, which is typically on the hour, at which point it then takes all of the tags that were seen, sends them up to Blues, and then we receive them on the cloud. So I'm weary about time, so I'm going to keep moving through this, but I'm happy to take questions about anything we've done or how this works. But this is our first use case for Blues. We have another product that also uses Blues, which is a totally different vertical, equally as fascinating. I'm going to jump into that one. So on the other side of things, we have a project called Insight 360. So this is a cetacean bycatch mitigation tool. So moving from humanitarian aid into conservation again. Insight 360 is a system designed to help fishermen at sea to report or at least improve the reporting of any bycatch incidents that occur. So when we say bycatch, what this means is the accidental capture of non-target species. So this could be a dolphin, it could be a whale, it could be sharks. This specific use case is targeted towards cetaceans. So we've been building the technology to focus on things like dolphins, porpoises, anything in the cetacean family. So this is a major issue for sustainable fishing. As you can imagine, catching animals that are not supposed to be for market is a big problem for fishing. The current reporting systems for accidental bycatch are incredibly difficult to use and are far from real time. What this has looked like before recently has been a notepad and paper, which gets sent off to CFAS, which is the UK reporting body for sustainable fishing. That could take months after an incident has occurred, if that even happens. You can imagine someone trying to write on a notepad and paper at sea while there's 3 meter high waves and the wind and wet rain are absolutely howling. It's just something that wasn't happening. So we were having very skewed reporting of actual bycatch incidents. Fishing also offers an important opportunity for us to understand exactly what's going on in our marine ecosystems. Fishermen are the people who are out at sea observing all of these species moving and the migration patterns of different animals, particularly dolphins and porpoises. So being able to get closer to their observations and understand from them what they're seeing gives conservationists a much better insight into what's actually happening at sea. So what we've been building with the UK government is a hands-free recording system that allows these events to be captured, even in rough sea conditions. So it's hands-free reporting with audio and video capture. So you can see here, this is a prototype of our first Insight 360 system. This is the 4th generation with the note card and star note inside of it. So at the moment, we are using a speech-to-text machine learning model. It's OpenAI's Whisper running on a Raspberry Pi 5. The 4th gen uses note card cell plus star note. This has been fantastic. We use the system not totally offshore, but for coastal reporting. We've been able to get back messages whilst the fishermen have been unable to report back via cellular. So when the note card cell stops working, star note takes over. That's been great because we've been also able to use the note hub to be able to see real time when things are coming through. Our system is based on sort of a Power over Ethernet peripheral based architecture. So the Insight 360 system itself provides Power over Ethernet to all of the peripheral devices. So we have the cameras and also the microphones that are on deck of the fishing vessel, so exposed to elements and potentially getting wet and exposed to seawater. So they provide audio, video, and then also we're using some RFID for some preliminary work using the nets to detect them when they get hauled back onto the vessel. Future versions will actually start doing image processing, where we start looking at the video feeds and try to observe things like dolphins in nets and if we see anything that's abnormal about the fishing incident. So it could be a case that perhaps the fisherman or the crew on board accidentally hauls an animal that's not supposed to be in the net. We're hoping to be able to detect that. That's work we started doing with Edge Impulse. It's really exciting and hopefully should unlock some particularly interesting insights into what's going on. Current prototypes are being updated at in the remote locations. So as you imagine, we don't have access to these fishing boats once they're deployed. We are using a full-blown cellular modem at the moment, along with Blina OS to update the applications and operating systems in the field. This is something we're hoping to move away from as we start to become more stable. The benefit of having Blues on board is it's affordable to have this at scale. When we have a cellular modem doing OS updates and full application updates, it's not something that we can see being affordable to deploy this at scale. And we're hoping to be able to roll this out across the UK and then ideally to fisheries that exist beyond the UK, so EU and further. That's all of my slides. The QR codes in the final slides of the GeoSeals and for the Insight take you to some project pages that have more information about these. But you can also check out arribada.org, and we have some blog posts talking about the technical work we've been doing and the impact of these different projects. So yeah, if there's any questions, happy to take them either now or at the end. And thanks.
That's great. Thanks so much, Alex. I think we can move on to our next panelist, and that would be Dr. James Powell. James started out in the laser industry in the late 90s following 8 years at Manchester University. I since spent over 2 decades involved in product design and manufacturing, predominantly in the solid state lighting industry, with a vertically integrated company covering most aspects of electronic product design and manufacturing in-house. James is now assisting numerous companies to enhance their products with cloud connectivity. And I totally did not just read that. All right, James, take it away.
Thanks ever so much. I'll just go share my screen to start with. And thanks, Rob, for the introduction. Oh, is that coming through okay? Is that being shared now?
I don't see anything yet.
Anything yet? That should be that
There it
live.
goes. Just came through for me.
Right, great. Yeah, well, Rob said I'm James, the Managing Director of J.A.P Lighting Technology based in Manchester in the UK. The company name is a little bit of a red herring, and we'll come on to that just now. Is I've spent pretty much 2 decades in the solid state lighting industry, both developing products for entertainment, retail, architectural, industrial markets, uh, both with in-house and as an OEM manufacturer. And just to give a little bit of a quick outline of what we've done as a company over the years is probably most people out there will have seen some of the projects that have been involved with. Started out in the early 2000s with Pixel Range, which was probably one of the most iconic first LED products to come out into the market. They were manufactured in the thousands of and were sold globally worldwide. Also did as a custom projects the U2 360 tour, which was 900 products for the staging for that concert, plus the LED microphone that Bono used throughout that tour. That was all electronics designed and manufactured in house. And to give you an idea in terms of capability, the 900 fixtures on that tour from a blank sheet of paper were designed and manufactured in about 3 weeks. So, very capable of doing very fast turnaround manufacturing. Celine Dion in Vegas, the entire set of that was LED product, again, completely custom designed, manufactured here in Manchester. And then anybody in the UK who watches the BBC One show, that's a product that was a complete in-house designed product. That product there has been illuminating the One show set in the BBC for the past probably 7 or 8 years, and is still going strong. That product there is a full colour mixing, networked lighting product with motorised zoom, etc. on there. So, and one of the most recent projects we did just before COVID was Grace Cathedral in San Francisco, which again was some sort of a standard product and again customized specific for that client. So that just sort of gives you a bit of an overview of what I've been doing as a company over the last 20 years, really. Bit of a shift over the last couple of years now with all the experience we've got as a company, starting to help people in the market look at cloud connectivity within their products. Obviously, from what you've just seen on the previous slides, as a company, we do in-house product design, hardware development, electronics hardware development, predominantly use Altium Designer, full 3D model for circuit boards. We do full firmware development, predominantly based on STM32, including RTOS, GUIs, etc. Got an in-house surface mount production line and can do box build from proof of concept right the way through up to volume manufacturing. And with clients we work with, we can do a complete blank sheet of paper to finished product, or we can fit in at any point. So if there's clients who are just wanting some hardware doing or some software doing, we can fit in wherever it works, or even just building prototypes, working with a customer at the moment that does their own firmware development hardware, and we're just acting as an in-house fabrication for prototypes and low volume electronics. So pretty much fully vertically integrated. So as I've just said, now sort of starting to lever the expertise within the company to assist clients realize their connected products. And we've currently got quite a few projects live, covering right the way through from startup companies to large multinational and PLCs. And that's both producing standalone products from a blank sheet of paper to also adding on cellular connectivity to existing products. A lot of the products that we're working with at the moment are covered by NDA, but I'd just like to thank Enable IoT, which is a company that I'm working with at the moment. We're a fairly new startup, about 2 years old, and I'm developing the hardware for Enable, which is obviously based on the Blues Note card. Enable IoT, they are predominantly in the agricultural market. They've got a fantastic back-end web system, AI-based, for doing carbon capture, soil monitoring, and quite a lot of fancy stuff for use in the agricultural markets. And what J.A.P are doing as a company, we're working on the hardware, which is basically the data capture for Enable to to pass data from out in the field back to their cloud-based data acquisition system. And that's obviously where my slides end at the moment. The Enable product, I hope everybody can see this. This is the literally version 1 product. And I say version 1, it is literally the first off the production line of this new data capture system for Enable. This obviously goes out in the field, either sort of pole mounted or wall mounted, depending if it's on sort of buildings in the agricultural market. It is completely self-contained data capture unit. Obviously, you can see we've got a solar panel on the front, lithium-ion batteries internally, and it's pretty much self-contained weather station. We've got a Stevenson screen on the bottom that does temperature measurement, humidity, pressure. I/O on the bottom to connect up to specialized research-grade soil sensors, rain sensor on the top. And based on the Blues note card. So this is a prime example of sort of the projects we're getting involved with at the moment. This started out by Enable approaching us with a very simple breadboard prototype. And they needed a partner to work with them to take something from very simple proofs of concept on a breadboard to something that is a finished product. And this is something that's been turned around in record time and is about to go out in the field, starting to do field trials. One thing to sort of point out to this product is it is a prototype, but in terms of the casing, you can see I work very closely with a company called Camden Boss in the UK, and they're very good for companies looking at bringing to market, like Enable as a startup, production-ready housings at a very, very competitive price. Rather than using sort of just standard ABS boxes. This enclosure has been produced by what's known as flat sheet technology, which is high precision machining, cutting, bending, bonding, etc. It allows clients to produce product very, very rapidly with minimal, pretty much zero tooling cost. And actually, Camden produce end product for EV charging modules that use this technology in full production. So, companies can get involved, get a product out in the market that is not looking like a prototype, but a completely finished product in the hundreds to, thousands of units before they have to have the expense of going to full injection molding. So, this is where we are with the Blues products at the moment. This is an example here of the internals. Obviously, you've got the Blues note card, I/O connection system to the external sensors, and as I said earlier on, we've got an STM32 product there, which is collecting all the data from the sensors, talking to the note card, and sending information up to the cloud for the AI analysis. So that's really just an example of what we're doing with Enable for their product. Gives you an idea of sort of where we can take a product from a concept to a proof of concept to semi-full production product in rapid time. And I think that really concludes sort of my short presentation. Thank you.
Fantastic. Thank you, James. And I apologize to Alex. I saw a question came in at the very end of his presentation. I might as well ask it now. The question is, this is a good question. What FCC type of or I guess what type of certifications did you need in Ethiopia and other places for your devices?
So I'll rewind this a little bit. We are still in the prototype phase for the Ethiopia project. So these are conversations we're starting to have. But that is a very good question because I don't know the answer to that yet. We only have a handful of these devices currently deployed. So as we start to scale up and look to roll out, we will need to know the answer to this. And hopefully I can share that with you. It's probably a useful thing to know.
Excellent.
And I have a quick question for James. On that unit, what part of it actually goes into the soil? Because it is a soil monitor, right?
Yeah, it actually has the soil monitor is a plug-in device. There's a couple of IP67 connectors on the bottom. So there's a separate device that plugs into, so that gets mounted on a pole in the field. There's a separate device which goes on a flying lead to a separate monitor that goes into the soil.
Excellent. Okay.
And that's the point on here. So again, if the customers want to add different sensors onto it in the future, it's very sort of future-proofed in terms of, square C, SDI connections on the bottom.
That makes sense. I'm guessing you did that partially because you want to get it on a pole to get better like solar access for that panel as well.
Yeah, and also, as I say, it's not my expertise, but in terms of the monitoring of the humidity, pressure, and temperature within the field, there's certain heights that the monitor has to be set to. So, off the top of my head, it's that 3 feet, something that the system really has to be that. It can't just be placed on the ground. So, hence,
Gotcha.
On that.
And then we did have a quick question coming in the chat. Somebody wanted to know again the name of the prototype manufacturer that makes the pre-scale devices.
Yeah, it's a company called Camden Boss. If anybody wants, there's my email on the starter presentation. If anybody wants to drop me an email, I'll pass on the contacts. A guy called Alex Woods down there, and they say they are great because, as I say, it gives companies a great chance of getting a prototype sort of looking like a finished product that can actually be sold as a finished product. As I say, they're doing EV charging pods now using this technology. It's very, very cost effective, even in sort of ones and twos off. And the good thing about Camden as well, they have actually got internal injection molding facilities. So once you get to a point, if you're luckily selling, the 1,000, 2,000, 3,000 products, they've got the in-house team that can take the design, do the tooling, and then produce full injection molding, moving forward. So it's a great thing, and as I say, that we work very closely with them on the one thing we don't really do so much now in house is the CAD and the mechanical design. There's people who are far better than our expertise is electronics, manufacturing, etc. Really more work with partners now on the mechanical side. It's their expertise, and say Camden do a fantastic job with this it's great flagship technology.
Awesome,
great, thank you. Hazel's up next. So Hazel Mitchell is a co-founder and director at Chronova Engineering. They're a UK-based prototype development company specializing in custom equipment for research applications. Hazel, go ahead and take it away.
Okay, so hopefully that's pulling up the slides now.
Looks good.
Yep.
Excellent. Okay, so hi everyone. Yep, as mentioned, I'm one of the directors at Chronova Engineering, and today I'll be presenting 2 IoT case studies using the Blues note cards. So just briefly, a little bit of background about Chronova Engineering. Basically, we're a prototype development company doing kind of mixed fields in engineering, so a combination of electronics, biomedical engineering, and more micro-scale mechanical engineering. We mainly specialize in creating devices for university and government research groups, but we also sometimes work with private clients, and we do some outreach related projects for our YouTube channel as well. The first case study I'd like to share with you is using a Blues-powered wireless sensor network for monitoring emissions from peatlands. So for those of you who aren't familiar with peatlands, they're basically a special type of wetland that's amazingly effective at sequestering carbon from the atmosphere into the soil. So despite covering less than 5% of global land surface area, peatlands actually contain more carbon than all of the world's forests combined. Over long timescales, this means that healthy peatlands have absorbed so much carbon that they have acted to have a net cooling effect on the Earth. But unfortunately, in more recent history, human activities have led to the degradation of peatlands, which now causes degraded peatlands to emit around 5% of anthropogenic greenhouse gas emissions. So obviously, this is a huge problem and something we want to address. And there's a lot of great work already being done to start trying to restore peatlands to a healthy condition. Unfortunately, though, there's still a lot we don't know about the optimum way to approach this issue. And the main reason is because the pathways that control emissions from peatlands are quite complicated. They're a combination of both chemical and biological processes, which are controlled by a wide range of environmental factors like temperature, soil moisture levels, acidity, and vegetation on top of the soil. And this leads to a very high variability across the sites and by time of day and season. The second major problem is peatlands, by their very nature, are incredibly wet environments, which makes them quite difficult to access and work in. They're not somewhere you'd want to be stuck working overnight or during storms. So we have a very clear need for autonomous monitoring in these environments. And then coupled with that, the tricky terrain makes it quite hard to use existing environmental monitoring tech, which usually requires large structures or quite extensive power supplies. So we wanted to look at scaling down existing emissions monitoring methods. So the way we've approached this is by using a wireless sensor network, which is made up of these small portable nodes. And each of these devices contains a Blues note card and the note carrier F inside it. And what the note card really allowed us to do was bring down the power consumption of these devices by putting sensors and microcontroller to sleep when we're not using them, and uploading all of the data in batches. We also use the GPS and orientation sensors in the note card for monitoring the status of these devices in the field. And of course, one of our goals with this was to keep the design very modular so that we'd be able to repair or customize them down the line. And building things up with the note card was quite an easy experience for us. So honestly, the most difficult part in developing these devices was cramming all of these different sensors into one portable box. So throughout this presentation, I've sprinkled in a couple of personal tips for using Blues devices. So I've tried to mainly address things that I haven't seen explicitly stated in the Blues documentation. But if you're just starting out for yourself, I'd strongly recommend you go look at the quick start guides and some of the accelerator projects for advice there. But yeah, one of the things I use a lot when I'm developing Blues products is the in-browser terminal. And this is great for being able to test what happens when a device is woken up from sleep mode, but without having to completely overwrite all of the voltage dependent behaviors that I've optimized on the device already. So yeah, just a handy little line, which if you're looking at the recording later, you'll be able to copy over and try out for yourself for testing sleep mode wake up behavior. And then a different piece of advice on the more hardware side of things: if you're doing a lot of prototyping, definitely print out one of these as soon as you can, because when you're doing lots of work with LiPos and solar panels, those little JST connectors break so easily. So yeah, printing one of these and using it really helps to reduce the strain on those cables. So the link there is the one that I normally use, but you've got lots of different options online if you prefer a different style.
That might be my favorite tip of all time, by the way.
It has saved so many cables, I swear. So yeah, moving on to my other case study. In the second project, we've been using the note card to monitor urban air pollution. So even when the air you're breathing looks clean, you don't really have any way of knowing that it is. Air pollution is actually a massive threat to global health and causes millions of premature deaths every year. In particular, particles under 2.5 microns in diameter have been linked to lots of really important illnesses, so heart disease, strokes, diabetes, and cancer. And non-emission traffic sources like road dust from brakes and tires has also been shown to increase the risk of health problems for children like asthma. So it definitely makes sense that we'd want to monitor the levels of these emissions in highly populated areas and regions around schools. So one of our clients is looking to do exactly that, and they came to us to get some help in building up these air pollution monitors. So these devices, again, are built around the note card's cell plus Wi-Fi, and they measure particulate matter, nitrogen dioxide, and carbon monoxide, as well as relevant environmental variables, including things like background noise levels. So the core of these devices is the note card cell plus Wi-Fi on the note carrier F. And all of the sensors are then connected via either I2C or UART, so it's quite easy to swap them out for different configurations. And Yeah, so here are two more detailed photos of these monitors. On the left is showcasing the modular attachment system that we developed for connecting these to lampposts of different diameters, but the same system can also be modified for attachment to different things like railings or sides of buildings. And on the right is just a photo showing you the internals of the device. And it's definitely quite interesting to note how little space the note card and note carrier is taking up in there compared to the sensors. So all of our data that we collect, we forward through Notehub to ThinkSpeak for doing our additional data hosting and visualization. The really nice thing about using ThinkSpeak for us is you can build these mini MATLAB apps, which can be run directly in the browser. So we can do lots of live data analysis without having to open any additional software. So two examples here in the top left, we've got doing simple correlation plots between pairs of variables, so like your pollution levels and the ambient noise levels. And towards the right, looking at things like recurring daily trends in any of the variables that you're interested in. So yeah, again, another tip for working with this kind of data, if you're looking at doing a quite power efficient approach like us, where you batch the data and upload it in bulk rather than uploading every measurement in real time, one thing you will need to do when exporting the data to an external service is exporting the timestamps along with it. So again, you might want to screen cap this or come look at the recording again later. This is a really handy way of just adjusting that data so that you can export the timestamps along with the measurements you've taken. So finally, just to wrap up, if you're looking at this and thinking, hey, I'm working on something similar, I'd be really interested in collaborating with you. Or even if you've got a wildly different prototype idea that you'd like to discuss with us, please do get in touch. To give you a quick idea of what it's like to work with us, we, rather than selling fixed products, we primarily offer completely bespoke devices. So everything can be configured to your needs, from the sensors to the enclosure and so on. And a lot of our clients are people who aren't very familiar with IoT or electronics. So we've very much tried to build our business around avoiding any usage-based subscription fees for our partners, and also making sure that all the devices that we deliver are pretty much ready to go straight out of the box without having to do any additional software. Our general process is we'll start out by arranging a video call or two to hash out the project, figure out what your requirements are, and any ongoing support needs that you'll have. From there, we usually build up a prototype device that we'll send to you so that you can familiarize yourself with it, test it out, and write up any feedback that you have for us. We can then implement any adjustments before we do the full production of all of the devices you've requested. And then finally, depending on what you've got planned for the project, we can offer a range of ongoing support, be that dashboard hosting or further data processing for you. So yeah, thank you very much for listening. Hope those case studies were interesting, and yeah, I'll pass on to the next speaker.
That's great. Thank you, Hazel. We actually had one question come in for the first case study about what's the purpose in that instance of using GPS to monitor something that is not moving?
You'd like to hope they're not moving. Unfortunately, some people have sticky fingers, is basically the main issue. Although we do have a secondary benefit of when people are having to deploy these devices and it's rainy, it's freezing cold, they're up to their waist in mud, putting these out in the field. Writing down on a piece of paper exactly what your GPS coordinates were at the time you put it out might not be the first thing on your mind. So it's also being able to locate them afterwards.
Gotcha. And we actually have the same question for you. Any certification, any end product certifications you had to go through?
Not at the moment. So yeah, all of our partners are looking at hosting these things privately. So these aren't being used right now in any kind of, in any settings where they need to be accredited, so to speak.
Gotcha. Excellent. Thank you so much, Hazel.
Can I just add as well, just to Hazel, I've just popped it in the chat that with the enabled product, we use exactly the same thing on the GPS, even though it is a static product in the field. It's used when the devices are being deployed, just to send a GPS coordinate back to base to say this is exactly where the thing is located in the field, and also if anything does get moved, it allows real time. So yes, it's a great feature of the product that we're using as well.
Great.
I can also add to that as well. We've had issues where we've had things that we think have been deployed in one place, but actually have appeared somewhere else, and we've been able to use Blues to work that out.
Awesome. All right, David Mackenzie. David's up next. So David is VP of Product Development at Prodigy, and they are a premier partner for translating groundbreaking concepts into real-world solutions. So their product development engineers integrate their expertise with your core competencies. They create industry-leading innovations that drive the future. David, feel free to take it away.
Great. Thank you for the intro. So let's just jump right in. Who am I? I am the VP of Product Development at Prodigy. I guess I've been around from punch cards to AI is kind of my perspective of automation. So I appreciate really the opportunity to speak here today. What is Prodigy? What do we do? We've been in business about 37 years, and we basically help clients develop products, everything from sippy cups to can making machines to snow throwers, a wide variety of products. So our mechanical, electrical, and software engineers and project managers do product development with and for our clients. Our clients are everything from individual inventors to large companies. We've generated about 750 patents over the years for our clients. We've done millions of hours of development and so forth. But what do we really do in the context of what we're talking about today? You know, in the stack of the Internet of Things, you start with the thing, right? Whether it's a test device, something out in the field, or a product, whether that's commercial or consumer, we develop the thing. So it might be a machine, it might be a test device, it might be a consumer product. But as you well know, more and more things are being enabled to work in the IoT space to solve a lot of the problems that the other speakers have talked about. So we not only develop the products, we now design in also technologies like IoT, and we also look at products out in the field and deploying retrofit solutions, especially in the industrial, space. There's a lot of room for building kind of a black box. You've seen several of those today, where we put in some hardware, like here's one of our own boards with a note card, and we can deploy it to fields in the machine and get an IoT pilot or a production scenario going very rapidly. So that's what we do. So enabling the thing is where Blues comes in. So like I just mentioned, there's retrofit projects, there's development projects, there's pilot projects, and the Blues note card really lets us be very effective. I can swap in and out without changing the firmware of the card, a Wi-Fi to a cellular or back to a LoRa and so forth. So what Blues is giving us and our customers is kind of that data pipeline. That's kind of the next layer up on the stack, right? The internet itself. And once you've got that built, that's when you can start finishing out your solution. That is building whatever it is, your cloud-based solution, whether it's a dashboard to monitor, a tracking tool. Maybe you're going to do some preventative maintenance and apply some AI and start learning from this data and so forth. And when we work up there, we partner with people. We're designing products. We're not developing cloud technologies from scratch, and that's why we partner. Of course, you're inevitably going to touch one of the big three: Amazon, Microsoft, or Google. If you're not, the IoT providers you're working with are going to be using them at some point. But then Blues and other platforms, or you may have your own cloud applications to connect to. So let's talk about the disruptions. So that was part of the theme of this webinar, is what are we doing with Blues technology that's disruptive? And there's plenty of examples. Some of these, due to NDAs, I can't really be too explicit, but you'll get the idea. One of the areas, I just laughed because I created that picture. using a Mid-Journey yesterday. You can see the gentleman has like 17 fingers. So sometimes it's pretty easy to spot AI generated things. But one of the themes that has kind of developed organically in our work is replacing PLCs. Now, not necessarily entirely. Sometimes it's a hybrid. Sometimes it is entirely replacing them. So, this new Blues product, which just came out, we're pretty excited about. The wireless for PLC teamed up with an Arduino Opta PLC gives us a lot of disruptive capabilities, being able to bypass, Wi-Fi and using cellular and so forth. But the other thing that we do is sometimes we develop our own cards that use Blues technology, and then we replace PLCs in their entirety. And I'll give you an example. One of our first IoT projects was a manufacturer of mobile dry ice blasting machines. And this goes back several years. And ultimately, we were able to design in IoT capabilities, amongst other things, all the electronics. So today, I took this screenshot this week. They've got over 2,500 industrial devices on 6 continents. When we first worked on this, it was a real challenge. I mean, 10 years ago, you weren't going to get one module that works globally. Today with Blues, I could have a global module that will work everywhere, and I don't have to change my firmware. I don't have to negotiate with a cellular provider. There's almost at least 1,000 cellular providers globally, so it's a big deal. So this client has definitely had disruptive effect in their industry because they're the only competitor that makes these things that does this. So they're able to give their clients preventative maintenance capabilities, monitoring, firmware updates globally, and so forth. Another client that used Blues in testing. So this is a product that was announced several years ago from a company called Ankra. And you can see on the left, there's a semi-trailer. The traditional way of loading it, you drive your forklift in, you back out, you step down, you grab a metal pole, you adjust the beams so you can continue stacking the pallets. If you have 100,000 trucks, though, in your fleet, if you can reduce loading time by 30%, that's what this was all about. So when we were developing this product, we used cellular technology to track the pilot vehicles and to tune our designs and so forth. So, this technology has use in production, it has use in piloting, it has use in testing and optimizing your product. The other thing a lot of people on this seminar have been talking about is the environment and applications. We're developing a lot of things with our clients and partners too. The Cleveland Water Alliance is someone we've just started doing business with. They're located in northern Ohio, and they develop products and work with partners to do all kinds of things on the watershed, whether it's on the rivers or the lake there and so forth. So there's a lot of technology, for example, like the LoRa module. I think they were somewhat influential in driving that capability to be in the Blues product. And that allows them to send data in very remote places, small packets of data at low or no cost, and so forth. On the right side, in the US, there's at least 3,000 electric utilities, 148,000 public water systems that mostly don't talk to each other. So there's a lot of opportunity to develop devices and to innovate and so forth. So while I can't show you the actual device, using a Blues card, we developed a device that could look at meters and using open computer vision as well as their AI and machine learning capabilities to be able to focus a camera at different types of meters and gather the readings, whether it's reading the dial, reading the little marker as it spins by, or doing OCR, or reading the infrared port. So as companies spend more and more time, trying to lower their carbon footprint and use electricity more efficiently, there's going to be a lot of interim solutions to get that data, because these 3,000 electric utilities not only don't share it because of business reasons, there's regulatory reasons why that data is not open and freely shared. And there's not just a product disruption with Blues. I would call it process disruption too that we can do, particularly in IoT pilots. A lot of us have talked about pilots today, and we do pilots with our clients, but sometimes they get lost. Sometimes they spend years by using technology like Blues. The Wi-Fi or the communication part becomes seamless. We can write our firmware very quickly, create our black box, hook it up to your device, your machine, your product to do a pilot. And then if we want to switch from Wi-Fi to cellular to LoRa back again, we can do that by just pulling out the card and plugging in a different card and so forth. So that's one of the things. And then just my final two slides. I was listening to this morning. Ray is the founder of Blues, and he's got a podcast that came out Monday where he's being interviewed about the future of intelligent machines. I recommend you listen to that because you really see where Blues come from and what these types of technologies, how they will apply in the future. And it's much less scary than all the AI clickbait, it's going to destroy the world kind of links that you see in social media. So finally, again, thank you for your time. Prodigy, we turn your ideas into products. We understand that today's products are part of a global digital ecosystem. We partner with best-in-class IoT leaders like Blues and others so that our designs can be efficient and deployed as quickly as possible. And you can launch a pilot in as little as 30 days. So thank you.
Fantastic. Thank you, David. Just to kind of wrap up here, I've got one more slide to share with you all. If I can do that quickly. Just providing some contact information, which I think I got. Hopefully that's working. Yes. So I will be sending a follow-up email out to everyone who's attended and who registered, and we'll include a link to the recording as well as some resources from all of our panelists today as well. If you have any, I know we have like 5 minutes technically left. If there's any last minute questions, feel free to ask them. But if not, we can end early. But actually, I do have one question in general for our panelists. I'm curious to know if there is and everyone does not have to answer this, but I'm curious if there's a specific customer profile or industry that you generally work with and what kind of the scope or scale of the product tends to be.
I can start. It's a wide range. I mean, we work with individual vendors to Fortune 500 companies. With that said, most of our clients are small to mid-size, and that's why products like this are important. And Ray talks about that in his seminar thing. Is it's kind of a democratization of technology. So much smaller companies, can now use IoT technology at a much more cost-effective way. I mean, everything's coming down in cost, right? Even 6 years ago, it was like 40 cents a megabyte to send data through some of these cards. And it's not at zero yet, but it's approaching it. And some like LoRaWAN, it's zero. I mean, if you're sending just small amounts of data once an hour, you're never gonna have to pay for that. So that opens up a world of opportunity. So
Interesting.
I think with me, it's the same. It's from small startups right up to, as I said earlier on, large PLC companies. Volumes are still quite low, even with the larger companies still in sort of development stage, sort of doing small quantity on site testing to prove it's quite new technology for these people. So a lot of testing being going on before the sort of larger scale rollouts are happening at the moment.
For us, most of the people we work with are smaller research groups. So sometimes they're based within charities or government organizations, but a lot of our clients are in industry research groups as well. But yeah, in terms of the scale of production, it's probably for us, we tend to do smaller scale deployments than most people usually think of with IoT. So normally you imagine IoT is going to be thousands of these connected devices. We're actually a much smaller scale than that. So deployments will be more in the region of 10 to 20 devices per client.
Can sort of add to that as well. So we're in a similar position in that we work with a lot of researchers, universities. Predominantly, our work is driven with a charity that's got a fund that drives a project, and then we come in as the technology arm to support. Often it's with a university that's driving the research, but we will be the technology arm to help develop the solution to do the research. And similar to Hazel, a lot of the stuff that we do is opening the gates to unlock further research. We've started now moving towards handling larger projects ourselves, but we did start off initially where we were handling lots of these like small prototypes, open the door for research, allow bigger grants to be won, and to enable future work to be performed.
Great. We did have one question slip in just under the wire here. This is for David. So does Prodigy also develop high quality web app user interfaces, including user management, subscriptions, etc.?
I'm sorry, can you repeat that?
Sorry, I read too fast sometimes. Does Prodigy also develop high quality web app user interfaces, including user management, subscriptions, etc.?
Yeah, we develop the full environment of the product, which includes building dashboards and things like that. We don't really sell anything by subscription or anything. We whatever we develop, our clients own. And so if we develop the product and then deploy the cloud app and our dashboard or a dashboard that appears on a phone, the client usually decides how they're going to offer it to their customers, as you will. Now we work with our clients like on a time and material basis, phase gate approach development. So yeah,
Great.
You can reach out to me personally if you want to have more detail. So
excellent. Well, thanks everyone for attending. Thanks especially to our speakers. I think this was fantastic. Again, you'll get a follow-up email from me, of course, later today or tomorrow. All right, have a great day, everybody.
Yeah, thanks everybody.
thank you very much.